All right, so for the review, we're going to start off with these working together problems. So number one says working alone, it takes Asanji 6 hours to dig a 5 foot by 5 foot hole. Brenda can dig the same hole in 7 hours. How long would it take them if they worked together? So remember, the formula for doing these problems is T equal to xy over x plus y. Right? That's our formula. X and Y are the times that were given. So just to put over here to the side, let's allow X and Y to be certain times. So let's see. Working alone, it takes Asanji 6 hours. So let's say X is 6 hours. Okay? And then it says Brenda can dig the same hole in 7 hours. Let me make sure I bring my phone out for calculations here. So I'm just going to plug in my x and y values into my formula. So T equals 6 times 7 over 6 plus 7. Well, that's 42 over 13. Okay, if I divide that, the time is 3.23. Now, I don't know. I'm trying to think back to the quiz because I did make the quiz, but I think sometimes I saw some answers that were 3.2 or maybe 3.23. Like, in other words, they may leave two numbers after the decimal, maybe just one. They round it. Okay, so you guys are going to have to look at your options. If it's you just have to write down the answer. You have to type it out. Remember, don't put the units. Don't write hours or anything like that. Just put 3.2, and that should be good enough. Okay. But if it's more decimal or more numbers after decimal, then go ahead and just kind of look to see what's offered and pick the right one. Okay. But there you go. Like, these are pretty easy problems. At least these types right here, where they give you both times. All you have to do is just plug them into a formula and simplify. Okay, so that's it. Now, let me give you a little bit of time to write down this next one. Okay, so now that you guys have had some time to write this down, let's go with this problem here. Sally and Dan were able to paint a room in 3 hours together. It takes Dan 4 hours to do his job alone. Without help, how long would it take Sally to do this job? So we know, again, we know our formula, right? T is equal to xy over x plus y. I know that T is 3 hours. Okay? And my x and y, I don't know both, but I do know one. So I'm just going to let x equal to Dan's time, which is 4 hours. That means I got to figure out what y is, which would be Sally's time. So let me plug that in. I got 3 equal to 3 times 4 over 3 plus 4. I'm sorry, what am I doing? 3 times, it's 4 times y, 4 plus y. My apologies there. I got ahead of myself there. So 4y over 4 plus y. Because I don't know what y is. I'll actually put it over here as a question mark. Okay? I don't know what y is. So I'm going to plug that in and I'm going to multiply. So 3 is equal to 4y over 4 plus y. And if you guys remember when we did this, what you do is you get the denominator and you multiply it over to the other side. So you're going to get this and multiply it. Okay, so this comes out to 3 times 4 plus y equal to 4y. Now distribute on the left side. Okay, so 3 times 4 is 12. 3 times y is 3y equal to 4y. And we're going to subtract 3y on both sides. So minus 3y minus 3y. So I got 12 equals to y. So that means it takes 12 hours. right? 12 hours. So there's our answer for that problem, 12 hours. So this one, it's not like the math is incredibly difficult. I mean, we multiplied 3 times 4 and 3 times y. It wasn't like insane. But we did have to do another kind of weird step where we multiplied an expression over, right? So that's a little different. But we were still able to find an answer, so no big deal. But you guys are going to have 2 of these types of problems, okay, where you have to figure out how long it takes one person to do it. And then you'll have 2 of these types of problems where they're going to tell you the time it takes both people, and then you got to figure out how long it takes together, all right? So 2 and 2. So if you feel good with this, then that probably means you're going to get 4 right for sure, right? And now we have to do, take a look at the other 12. So one of the questions you guys are going to be given is going to look like this. Okay? And the question is going to say, what is the 4, or what does, let me put it this way, what does the 4 represent? Now it's going to be a multiple choice thing, okay? So you might want to say, well, the 4 means the 4th root, but that's actually not what they're asking. There was a definition that tells you what that number 4 is called. Anybody remember? An index. Okay, so that's what your answer is supposed to be, an index. Okay, so that number 4 represents the index of the radical. Now you don't have to type this out, don't worry. It's going to be multiple choice. It might say the power, the index, the radicand, or something else. Okay, so you just got to click on the one that says the index. Okay, so there's going to be one question that is going to look like that. There's going to be another question. I think it's multiple choice. And they're going to say the information inside the radical is called the, and then they're going to have a blank. And again, I think it's going to be multiple choice, so you're just going to have to look at your options. Okay? But what would my answer be? Inside the radical, what is that part called? So, I mean, you can look at your notes, right? Well, what's the inside of the radical called? This part right here. The radicand, right? So it's almost the same word. It's just the word and at the end. So it would be called the radicand. Okay? So those are 2 other problems you're going to be asked. So make sure you guys review those. That way tomorrow you can get those right. So that means hopefully right now you'd have 6 out of the 16 correct. Now you got 10 more to have to kind of worry about. So the last set. So there's a couple problems that are going to be pretty easy. Now I say easy depending on how much notes you have and stuff like this. But there's going to be some that are just going to say, what's the square root of 25? Well, what's the square root of 25? 5. Okay, good. Like literally there will be questions like this, okay? Square root of 81. What's that? 9. So if you can do that, then you should be able to get a couple more points right too. Because there will be some that are pretty easy. But there will be also some that are just numbers that are going to look like that. And you're going to say, oh, 45. Then you think, is there a square root to 45? No, there's a square root to 49. And below that, there's a square root of 36. But there's no square root of 45. So you're going to be expected to break it apart, right? So you're going to say, okay, square root of 45, I can write it as two numbers multiplied together, but one of them has to have a nice square root. What two numbers can I use? 9 and 5. Now, the square root of 9 does have a very nice square root. The square root of 9 is 3, right? So this is going to be 3 radical 5. So you will get questions like that, okay? So make sure you guys are practicing little things like that. Like, what if I tell you like the square root of 20? Right? There is no square root of 20. There's a square root of 25. There's a square root of 16, but no square root in between. Okay? So what two numbers can I break up 20 into? 4 and 5. Okay. And we know 4 has a nice square root, right? So let me kind of highlight that for us here. So the square root of 4 is what? 2. And then we got radical 5. Okay? So these are some of the things that you're going to have that have square roots in them. Okay? Now after that, they're going to say, okay, enough with this easy stuff, right? They're going to consider this easy. Let's start to make them do some work that is a little tougher. Okay? So you're going to get some problems that are going to look like this. Let's say square root of 40 x cubed y to the 4th. And they're going to want you to simplify that. Now remember, since we're dealing with variables, now we have to remember what is the index on my problem. Now, since it's a square root, what's the index? A 2, right? So, yeah, you could say square 2, but it's not a square per se, but yeah, same idea. So I'm just going to rewrite it just as a reminder. And now I have to start thinking, okay, we got to break down this number into something that has a nice square root. Okay? And then I got to break apart my x and my y values so that they have what power? What power do I want my x's and y's to have? Anybody know? A 2. We want our powers to be a 2. Why do we want them to be a 2? Because the index is a 2. So if I can make the index and the power match, that allows me to take stuff out, right? So here we go. Give me two numbers that multiply to 40, one of which has a nice square root. 4 and 10, thank you. All right, x cubed. Well, I can write it as x squared x. That's x cubed, x squared x. And y to the 4th, I can write it as y squared y squared. And remember, this is an index of 2, so let me just kind of highlight here just so you can see how many things I'm going to take out, and then this 4 is going to come out. So let's go ahead and, I used to always draw these arrows for myself when I first started. I mean, obviously now, maybe not, but at first that way I kept track of what's leaving, right? So here we go. Square root of 4 is 2. And then an x comes out, a y, and another y. If you want to write y squared immediately, feel free. I'm just kind of showing the work. Square root of, what's left? 10, or 10x, right? So my final answer would be 2xy squared, square root of 10x. Now these are considered the hard problems. Okay, so I mean, if you're like, oh, it's not too bad, then great. That means you're going to do good tomorrow. All right? But these are considered the tougher ones because not only are you dealing with numbers, but you're also dealing with variables and stuff, and you break down variables so that they can match the index. So yeah, those are considered the tougher problems for your test. Now, there could be some stuff that has, and this is going to be the last one I'm going to show you guys. So let me do Number 10. A cubed root of 16 x to the 5th, y to the 3rd, z to the 7th. Let's just make this, I guess, as complicated as possible. So the cubed root of 16 x to the 5th, y to the 3rd, z to the 7th. Remember, my index is a 3. That means all my powers on my variables need to be 3's. Okay? Now, do I have a cubed root for 16? No, right? Hold on. I'm just rewriting the problem here, so don't worry. So I don't have a cubed root for 16, but can I break 16 down into two numbers, one of which has a nice cubed root? What is it? 2 and 8. Which one of those has a cubed root? The 8, right?
Is it 16 already a square?
Yeah, but we're doing cubed root. Cubed root, not square root. If it was a square root, that'd be perfect because the 16 would come out as a 4, right? But in our case, we're doing a cubed root. So we're going to break this down. 2 times 8. Now my x's have to be powers of 3, okay? So x to the 3rd, x squared. Okay? And then y to the 3rd, well, that's already a 3rd power, so that's perfect. Z to the 7th, what should I write? Okay, z to the 3rd, z to the 3rd, and what else? Z squared, okay. So there we go. I know it's a big old mess. Like I said, there's shortcuts to this. You can write z squared to the 3rd. That's the same as z to the 3rd, z to the 3rd. But I just figure, list it out. It's not that much work. So here we go. Index of 3, power of 3, power of 3, another one there, another one there. And then my 8 gets to go because the cubed root of 8 is 2. Okay? So everything that's leaving is here, here, there, there, and there. 1, 2, 3, 4, 5 things are leaving. Okay? So let's list them. The cube root of 8 is 2. An x comes out. A y comes out. A z and another z. What's left inside my cubed root? Okay, 2x squared. Z what? Yeah, look right here. Z squared, right? I don't know if you guys said it, maybe I didn't hear it. But yeah, it should be z squared. That's what's left. Oh, did I do 8? Oh, my bad. Mistake. I was testing you guys. You passed? No, my mistake. So, hold on. A, P, gotcha. Okay. So, extra credit for corrections. Let's go ahead and finish this off. I'll make sure I edit out the video later so it doesn't sound like I made a mistake. No, it's always, I'll keep it there. I love when I make errors. Not that I look to make them, but when I do, you know, when I was a student, I always used to appreciate a teacher messing up because that meant if they can mess up, so can I. Not that I want to do that, but you know, I wouldn't feel bad if I made mistakes because even my teacher was doing it, right? So there's your answer. 2xy z squared cubed root of 2x squared z. Okay? And this is what your test is going to be on, or your quiz is going to be on tomorrow.